Hello, in this video we're going to look at how to solve for an investment's expected value, standard deviation, and expected utility. So here is our investment. There are three possible outcomes with this investment. A 20% chance that it'll pay off $600, a 60% chance of $300, or a 20% chance of $100. We want to calculate the expected value, standard deviation, and expected utility of the investment. The consumer or person's utility function is given by the following. Let's start with the expected value, which is just the probability weighted average of the payoffs. So 0.2 times 600 plus 0.6 times 300 plus 0.2 times 100, we get $320. That is the expected payoff or expected value of this investment. Moving on to the standard deviation. The standard deviation is the square root of the variance, or the square root of the sum of the probability weighted squared deviations of the payoffs. Note here from our first slide we saw that the expected value equals 320. First, we're going to solve for the variance. So it's probability weighted. So we're going to use these probabilities here, 0.2, 0.6, and 0.2. And it says we're summing these weighted square deviations. So in the parentheses here, the 600 minus the expected value, that is what is being referred to as the deviation from the expected value. So how far does 600 deviate from the expected value of 320? So we're going to calculate that, and then we're going to square it. And then we do the same thing for the second payoff here. This $300, how much does it deviate from our expected value? We're going to have that calculation here. And then finally, we do a similar thing with the $100 payoff. So plugging in our values for the expected value and simplifying, we get a variance of 25,600. To get the standard deviation, we're simply going to take the square root of that value, and we get 160. The last thing we'll do is we're going to calculate expected utility, the expected value of the utility levels. So here is our utility function, and the expected utility is going to be 0.2 times the utility function evaluated at a payoff of 600, then 0.6 times the utility function evaluated at $300, and finally 0.2 times the utility function evaluated at $100. So here is our utility function, plugging in 600 for income. Here again is our utility function, but this time plugging in 300 for income and doing the same thing for this last payoff of $100. Number crunching this, we get an expected utility of 34.6 units. Okay, I'll stop here.